Okay, thanks, Nabil. Yeah, so I think as Nabil mentioned, go ahead and ask your questions in the Q&A. I'm not going to pause during the presentation to answer questions, just so that we make sure we get through the whole presentation, and then hopefully we'll have 5 to 10 minutes at the end to deal with any common questions that maybe we have. And then, yeah, we're always open for any kind of follow-up. You can contact your solution architect. If you're a ConfD customer, there's the ConfD community forum. So there's a number of places where you can try and get uh, follow-on questions answered. So yeah, we'll talk about NMDA. So uh, as Nabil mentioned, NMDA is the Network Management Datastore Architecture. I'll just refer to it as NMDA because otherwise it's a mouthful. It was defined in RFC 8342, which was published in actually March of 2018. So it's a little bit over 3 years old, but it's still sort of propagating and making its way, I think, through NetConf uh, implementations and client software. We actually gave a presentation during our last developer days that was held prior to COVID-19 when things still happened in person back in October of 2019, just before we released our initial implementation portion of NMDA and CompD 7.3 later that year. So um, there's also additional extensions, obviously, that to be able to support NMDA that were made in NetConf and RESTCONF. And there's two RFCs that deal with that, and we'll talk about those. Um, there's also been, because NMDA has implications for the way, at least like IETF Yang models were written. So one of the things I'll do during this talk is kind of use the interfaces Yang model pre-NMDA and then post-NMDA to illustrate kind of some of the differences that NMDA introduced. So just as a reminder, prior to NMDA, there were originally three data stores. There's the startup, running, and candidate. Um, Only running was mandatory. You could optionally choose to make use of startup or candidate. Uh, if you were using candidate, then you could actually make running read-only and sort of inject all the changes um, through candidate by making the changes in candidate and then committing them. All three data stores, though, only contain configuration data, so the kind of config true nodes that you have in your Yang models. And at the time, originally, config faults or operational data didn't have its own data store. So it was just kind of information that was kind of a local implementation detail for how the system would actually supply that information. But um, uh, the, the data didn't reside in a data store as defined by um, any RFC. So just a picture of the data stores taken right out of the RFC. Uh, Again, they're only holding config true information. Um, they all can be sort of written to, startup, maybe not directly. It's usually copied from running, but they do have kind of this relationship amongst each other. So one of the things that happened, obviously, as NetConf was uh, made available in RC 4741 originally, as the development of the Yang modeling language proceeded and eventually was published in RFC 6020. Then there was an update to NETCONF in RFC 6241 to produce NETCONF 1.1. But again, a lot of feedback and experience have been gotten over the years working with NETCONF. And one of the other things that happened around the time the NETCONF 1.1 RFC was produced was a document entitled The Architecture and Architecture for Network Management using NETCONF and YANG. So that previous picture that we had of the relationship between the three existing data stores seems pretty simple, but there's actually more complexities. First, there was a recognition that you might make between sort of configuration data and operational state data, as well as statistical data. So configuration data is just the typical configuration that's written into one of the data stores, and then it's used to transition the system from its sort of whatever initial state into its current state. Operational state data can also represent other data that's obtained by the system kind of at runtime. And this may actually have, similar system behavior to configuration data. But because it's operational state data, it may be transient, and it could also be modified by interaction with other internal components within the system or via specialized protocols, for instance, setting the IP address using DHCP. So you have that kind of set of operational state data, but then you also have, the traditional kind of statistical information that we kind of think of going back to the SNMP days of knowing the number of packets in or out, or, packets that, amount of bytes sent and received, things like that. One of the things, though, was introduced by kind of lumping everything, both operational state data and statistical data, into sort of the config faults part, is that there's no real good way to distinguish between what might be state data and statistical data. So this RFC, which I'd recommend if you're really interested in understanding some of the background to NMDA, is to go ahead and read this, because they actually looked at a number of solutions for sort of managing this problem. And we'll take a look at how this manifested itself in the interfaces, just so that it's a bit clearer what's the problem being described here, because this is, again, a little abstract. So, and it may be confusing. I mean, certainly it was confusing to me when I first sort of encountered this and started thinking about it. So, but again, the RFC looked at a number of different solutions for handling configuration and sort of operational values. The solution they ended up choosing was to kind of keep the data in sort of two separate kind of parallel branches, basically. Excuse me. The configuration leaf would indicate what, sort of the desired value of the thing that's been configured by, say, a client. And then the operational leaf would just indicate the current value that the system is currently exhibiting. One of the interesting things is, this approach that was kind of chosen and ended up being used in some of the IETF Yang models. The idea of an operational state data store was actually one of the options that they considered and also rejected. But as we'll see, they kind of revised their thinking on this. So we'll spend a little bit of time looking at RFC 7223, which is a Yang model for interface management. So again, this is pre-NMDA, but it's post this other RFC that I mentioned that defined kind of a architecture for using NetConf Yang. So if you look at this RFC, you'll see that there are actually kind of two containers that each contain a list. One is the sort of configuration aspects of the device, of the interfaces. So that's the thing that a client, NetConf client, for instance, would write a configuration into. And that's the interfaces interface list. Then there's the sort of operational aspects. So what does the device think is, happening on the device? What's the current state of the device? And again, that's in a different container, the interfaces state container, and the interface list replicates the information from the config list, but it also adds a lot of other information that's relevant to the state of the interface. So things like statistical counters are included there. Other things like, whether it's the operational state of the interface is up or down, the administrative state is up or down, and those kinds of things. But if you read the RFC carefully, you'll notice that they make a couple of additional distinctions when talking about interfaces. One is that you can have interfaces which are system-controlled interfaces, and this is the terminology they use in the RFC. So the system may create and delete interfaces independently of what's being explicitly configured. So for instance, you might have a software loopback interface that's just defined by the system. It just exists. It doesn't have to be configured. It just is present. You could also have interfaces which simply get created by the insertion of hardware. So they don't have to be configured, but the presence of the hardware will cause that interface to exist. Then you also have, what we typically think of as, the user-controlled interfaces. Those are the ones that are explicitly configured using a netconf edit config operation on the kind of config container. And you can, add or remove interfaces by dealing with that part of the model. Okay, so again, we have kind of interfaces which may exist on a device or a system independently of whether they've been configured. So that's just a recognition that those kinds of things do exist in real life. And then you have the kind of interfaces that, you do explicitly need to kind of configure that to bring them into existence on the device. So again, this is just kind of showing, the fact that you have this kind of parallel, set of lists, and then, of course, this is simply a subset of what appears in the RFC, but it just gives you an idea that, the idea is that there's this kind of parallel universe almost between the configuration and then the operational state. Another thing that the RFC talks about is pre-provisioning. So for instance, you may, if the device supports it, because this is a capability that it will advertise. So it's not a mandatory thing, but for instance, if you're implementing RFC 7223 and your device does support pre-provisioning, you might go ahead and configure an interface, even though the physical hardware is not present. So one thing to realize is the interface's state shows all the existing interfaces on the device. So you'll have system controlled interfaces, You'll also have user-controlled interfaces, which actually exist. So if you pre-provisioned something, but the hardware's not inserted or present on the device, then that interface won't show up in the interfaces state list. But the other thing to realize is that you may want to actually modify a system controlled interface. So for instance, say a software loopback interface, it may have a default address of just 127.0.0.1. You may want to change that to some other address. What you can do is put an entry into the sort of configuration branch. So as long as the name matches between the system supplied interface name and the interface name that you put into the list, you could actually kind of modify or override that configuration. So what happens is that the system is then responsible for kind of merging those two things, the thing that it already knows about because it's system supplied, as well as any configuration where a user may have tried to modify some default configuration. So it could be the IP address, it could be just a description, you may want to supply a more accurate description for an interface. So, so there's sort of that aspect. So as you can see, the world gets, a little bit complicated because you've got not just user supplied configuration, you've got system supplied configuration, you've got pre-provisioned configuration that may not actually exist yet on the device. You may have attempts by the user to kind of modify a system supplied interface. So all those things come into play if you do a full implementation. Of course, many devices could be much simpler than this, but I think the thing that IETF is trying to do is to look at, the sort of general case, what could be there in the network, what certain vendors could be doing with their devices, and trying to ensure that the models are written in a way that allow and can take into account these different kinds of behaviors. But also, I think as some experience was gained with this approach, people realize that there's actually kind of problems with this. So this might be a pattern that you'll see in IETF Yang models, but it's not sort of enforceable. So vendor supplied models that should have this kind of parallel sets of state and configuration may not implement it. You may also be making problem mistakes when you're augmenting the models because you need to make sure you augment the sort of configuration part as well as the state part. And also that there's no way other than sort of textually, maybe in a comment or something, by saying, what's the relationship between these two containers and these two lists. So, NetConf Manager can't necessarily, automate this kind of merging activity between these two lists and understand what's happening. You have a duplication of information in the two lists. So if you don't do the duplication properly, maybe, it introduces kind of mistakes or problems. And then, lastly, as you can kind of see, if you're a manager, you really need to look at both lists. You can't simply look at the configuration part. And you can't necessarily even just look at the state part to kind of understand what's happening with this device. So that just introduces an additional complexity of kind of, being able to sort of diff the two lists. So, given all those problems, and I think the IETF in the working group, at least in its wisdom, realized it maybe had digging itself a hole, and it decided to take a different approach, and that was to introduce NMDA, the Network Management Datastore Architecture, as defined in RFC 8342. So again, realize the limitations of the previous approach, but they still wanted to be able to distinguish between, the value as it's configured by the user, and also the value that's actually present on the device. So, principally, it's still trying to answer the same problem that we mentioned going back to the earlier RFC on the architecture. But they decided to go ahead and to take one of the other options, I guess, that they considered that they didn't choose initially, which was to kind of introduce a new architectural model for data stores. This allows you to go ahead and just model data just once in a schema, but that you could have sort of independent instantiations that appear in different data stores. So you have a data store for configured values, you have a data store for the operational values, but it's all modeled by the same model instead of having sort of parallel sets of configuration. Now, one of the things I think people had gained some experience with too is in implementations of NetConf. Some of them introduced sort of, say, product-specific ways of creating templates that would expand to be configuration that would be applied, and also to be able to have configuration exist on a say the running data store, but be marked as inactive because currently maybe you didn't want to make use of it. So as we'll see, ConfD does allow you to do the sort of mark configuration as inactive. So the NMDA data stores, of course, we kept the original. Those weren't changed or removed, and the interactions between them were all preserved. But two new data stores were introduced. So there's the intended data store and the operational data store. The other thing that the IETF did was they designed this new data store architecture to be extensible. So you could add new user-defined or IETF-defined data stores in the future so that we wouldn't have to have a new NMDA at some point when a new data store wanted to be added. So, and we'll talk a little bit about those mechanisms. So going back to our, original sort of ASCII art picture, we have the original 3 data stores at the top, and then below that we have both the intended data store, which is derived from running, and we'll talk about how that's done. And then we have the operational data store. So the interesting thing about both the intended and operational is that they're intended to be read-only. They're not directly writable by a NetConf operation. But intended still contains only config true data. But operational obviously contains the config true plus config false data. And you could see that with operational, there's a lot of additional sources of, I guess, information that kind of flow into the operational. So it's both the intended configuration as well as these dynamic configuration data stores that could be user supplied. And as well as there's other sources of configuration that we knew existed on devices. So there's, the system configuration, there might be some default configuration. There's could be learned configuration, meaning it's learned via protocol operation, say like by DHCP or maybe a routing protocol. All that feeds into the operational data store. So we'll unpack all this. So don't panic yet. Intended data store is a configuration data store, as I mentioned, just like the original 3 data stores. So it's only holding configuration true data. It is read-only, but it's closely related to the running. So as I mentioned earlier, some NetConf implementations have this notion of a template that could be expanded and applied to a configuration. If you have such a template mechanism, the idea is that you expand the template when it's applied, and that's expanded template is included in the intended data store. Also, if you have any configuration in the running data store, but it's been marked inactive in some way, that data will be removed. So the intended is really, it's a validated configuration that the client application, coming again from the northbound interface, NetConf interface, intends to be in effect. So in a simple implementation, running and intended may actually be the same data store. And in ConfD in practice, I mean, unless you're making use of the inactive metadata attribute that you can apply to configuration, that's going to be the case. So the operational data store, again, talked about RFC 6244, it was considered as a potential solution. So it's not a new idea. It's been around, at least in the hallways at IETF for a while. It's also read-only, just like intended. And it's comprised of the applied configuration, as well as any system state. So this notion of applied configuration is defined as, the configuration data stores, like intended, plus any learned configuration, for instance, through some kind of protocol operation, any system configuration, as well as default configuration. And then the system state is defined as the sort of read-only status information, like whether this is, operationally up or down, whether, and all the statistical information, usually associated with things like an interface. So again, going back to this notion of system-controlled resources, these are resources that are controlled by the device or the platform. It may be related to, hardware that's being present, software loopback interfaces, and again, these things could be dynamic. So they appear in operational because, obviously hardware can be removed or inserted. Applications running on your platform or on your device may be creating interfaces as well. But as we mentioned earlier, these resources that are sort of in the operational data store and are kind of dynamic, you may have need to kind of also control their configuration as well. So for instance, as going back to our example of a loopback interface, you might want to create give it a different IP address than the default that's typically assigned to that loopback interface. The other thing that's happening as well is, interface or configuration ends up in the intended data store. There may be kind of a delay sometimes in the system actually applying that configuration. So only once that configuration actually is really been applied will become part of the operational data store. And this is kind of an insight that the OpenConfig community kind of fed into this discussion because, there was a recognition that sometimes there's a lag between the time a configuration may be made on a device and when that actually takes effect. And sometimes that can actually not just be a matter of milliseconds or seconds. It could be a matter of waiting for a particular resource to be available in the software stack or something like that, which may cause a delay in the configuration being applied. So we now have, let's just go back to this picture. When you're looking at the operational data store, you realize there's a lot of stuff flowing into this. So when you're reading, for instance, from the operational data store, you might like to know, where did the source of this information come from? Was it coming from intended? Did it come from some kind of systems configuration or learned configuration or some other source? So an additional part of NMDA is this origin metadata annotation. So when you're retrieving information from operational, it may be, it's going to be difficult to know where the origin of that data came from. So for a client to know that, all the configuration nodes in the Yang model should be marked. And again, should is, it's not mandatory, but again, it's, highly recommended. And it's supported by ConfD as well. Should be marked with this origin metadata annotation that specifies the origin. So again, this applies just to configuration nodes because anything that's config faults that's coming from operational is by definition coming from the operational data store. It's not coming from any other source. So again, when you're retrieving data from the operational data store, this origin information should be returned. And we'll see an example of that. I'll show you how that information shows up in the replies. So now that we've got a new network management data store architecture, you'll notice that the next RFC numerically that came right after NMDA was a revised Yang data model for interface management. So this is a revision of the earlier RFC that we talked about that conforms to NMDA. So again, they're making, again, the same distinction between system-controlled interfaces and user-controlled interfaces, as well as pre-provisioning and all the other aspects that we talked about earlier. What they do in the Yang model, though, is they actually deprecate the old interfaces state container that contained that list that contain all these sort of operational aspects of interfaces. And what they've done is taken all the config faults nodes that kind of lived in that subtree and put them into the interfaces subtree. So again, that's the whole intent of the new data store architecture, is to simplify the Yang model aspects, to have this kind of unified collection of both the config true and the config false parts of the and also the user defined as well as the system defined or supplied aspects of any Yang model. Because it's only deprecated, obviously a NetConf server could still, implement this RFC and implement the deprecated subtree, either if they don't support NMDA or want to support clients that don't understand NMDA. Okay, so I see that there's a poll going on, so go ahead and answer that. And um, and like with a lot of RFCs, typically at the back of the RFC in appendices, there's examples. So this RFC actually has an example that's in its Appendix E that shows how to use this origin attribute, and we'll kind of illustrate a little bit how that works. But again, I don't know, maybe I've been doing this for too long, but I actually find these RFCs fairly readable. So again, I'd encourage you, if you're interested in kind of diving into the details of any of this, is to go ahead and just read the RFCs. The amount of text data is usually not very large. I mean, the RFC may be, 30, 40 pages, but, some of that may be, largely the Yang model. Although reading the comments in the Yang model can actually be useful too, especially for these interface management RFCs or Yang models, because there's actually a lot of information stored as comments. So this is just kind of a snippet showing this new interfaces subtree. So you can see that there are a number of read-write attributes that were carried over from the original Yang model, and then the addition of all the sort of read-only or the config faults things that were actually into the sort of parallel tree. And that's all been sort of merged into this to provide sort of a more unified view. Now, one of the things to realize is that, with the new Datastore architecture, we had to kind of enhance NetConf and RESTCONF. Oops, misspelled RESTCONF there. To support this, because the original NetConf RPCs were written only with the original 3 data stores in mind and didn't really weren't set up to be extensible. So and same thing with RESTCONF. RESTCONF just has kind of a unified view of all the data stores. It doesn't really allow you to specify which data store an operation is against. It just says, fetch this data or set this data, post, put, whatever HTTP operation, and that will just be applied to the system. So with NetConf, what this is done in RFC 8526, and we introduced 2 new RPCs. One RPC is get data, which is sort of simple, similar to get config, but it does support an extensible set of data stores. So, for instance, you could supply intended, you could supply, operational as where you're wanting to fetch the data from. The other useful thing it does is it introduces some new options for filtering. So you can filter based on origin, for instance. So you could say that I want to see everything in, say, the operational data store that has an origin of intended or system, for example. So, And we'll see, I'll show a brief example of this, of a response that you might get back from a get data. The other new RPC is edit data. Again, it's only working on writable data stores, so you can't write directly into intended or operational, but it was set up to be extensible because, again, we had this notion of a dynamic configuration data stores that might exist on the system. Uh, so, yeah, I think they tried to make sure that they didn't paint themselves into a corner when defining this new RPC, that it couldn't be extended in the future to cover other cases. So let's look at a specific example of get data, and we'll see how the sort of origin metadata is used. So here we have a get data where we're specifying the data store that we want to fetch the information from as operational. And we're going to just look at a subtree. We're just going to look at BGP. So again, you can see the presence of the origin filters. So you can repeat these. So, we have both the I'm sorry, we're going to retrieve both the intended and system origins. And then looking at the reply that comes back, we sort of unpack this. So here we remember the origin attribute is applied to config true nodes that are in your Yang data model. So, with BGP, we're going to tell it to, it's telling us that everything at this point is from the intended data store. And basically the way the origin works as well is that any child node has the same origin until you've supplied a different origin. So here we have an example where there's been a configured peer with a particular name. But as you're aware, typically in when you're setting up, the socket connections, the local port is actually, it might be useful for purposes like if you're using some kind of tool looking at data packet traffic to know which is the source or the destination port, depending on the direction. So, but it's typically going to be assigned by the system. So the local port here is reported as 6794, but it's marked with the origin attribute of system, saying that this was not a configured attribute. It was actually just supplied by the system. And then the state doesn't have an attribute or an origin because it's actually just operational, and we don't have to report origins for operational data. And again, take a look at the RFC. It's got other examples in there illustrating how the origin attributes made use of. So RESTCONF actually is a little bit simpler. So if you take the whatever the resource you've assigned, there's a new data store resource, as well as some additional, again, query parameters. It also requires the use of Yang library. So instead of examples or extensions, I guess, is not as broad. It's just mainly the new data store resources and the query parameters. So how does ConfD implement all this? So as I mentioned, we first discussed this back in October 2019, a little over a year and a half ago. This showed up in a ConfD release later that year, which is ConfD 7.3. But the relationship of running an intended in ConfD, and I kind of touched on this earlier in the discussion, we don't have support for configuration templates or any other kind of extended mechanisms, for applying configuration in a system. So that notion doesn't really apply to ConfD, but oops, I see I didn't quite finish my sentence there, but ConfD does support inactive attributes. So if you're making use of the inactive metadata, then ConfD will filter out those nodes that are marked inactive when you do a get data, on the intended data store, and those things, in fact, won't show up in operational either. So if you don't make use of the inactive attribute, then get data on running and intended will be the same. I mean, you won't see any difference between the two in ConfD. So again, we have this data stores revisited diagram. So remember, you've got a lot of other sources that are feeding into the operational data store. Intended is one of them, other learned and system and default configuration aspects. So operational in ConfD, again, if you're talking about config false nodes in your models, if you have an existing data provider that's, again, this is ConfD talk. If you're making use of our data provider API and supplying information, especially like statistical information, then ConfD will continue to just invoke your data provider for that. Now, if you have config true nodes in operational, you have two choices. By default, if you do nothing else indicating in your models, we'll just return the config true data from intended, the running data store essentially, which is the correct thing to do in many cases. If you're making use of the kind of flexibility that NMDA gives you to have system supplied information such as, system supplied interfaces or things like that, then it gets to be a little bit more complicated. So then what we've introduced is a new annotation that you can put on a call point called tailf operational. What that means is that ConfD will invoke that data provider when the config true nodes in your model are being accessed from operational. So that gives you the flexibility to kind of report the kind of current state of things from the operational data store point of view, even if that might be different than what's in running or intended. So if you're going to be, if a client though is going to be fetching data from running or intended, ConfD will continue to just use CDB. But if you're going to invoke the operational data store, then if you've indicated with this annotation of tailf operational, then the data provider will be invoked. Now, we realized that this was kind of a little created more work, I guess, for you as an application developer. So there is work underway to kind of allow you to store learned or system configuration in CDB. So, basically it's, using the same models, you would just store it, but you would annotate it in a way so that ConfD understood that, for example, this interface is a system supplied interface, not, one that's been configured. And then ConfD would just simply retrieve and return on the information by just looking at CDB and doesn't have to interact with any applications on your platform. But that's, again, future work. I think it's targeted for the next upcoming release, 7.6, which will be in mid-year, and we'll talk about that a little bit. And again, we have capabilities in ConfD to, you might have models that are going to be purely operational. For example, there's an IETF hardware model. You can introduce there's a new flag that says this is just a data store operational model, and it won't be used to store any data in running or intended because it's just an operational data store. So we do have a lot of examples. So I kind of listed the examples here in little notes on what they're illustrating. So again, in the upcoming mid-year release of ConfD, we expect that there'll be again, hardware management model that's going to be making use of this ability to indicate in CDB that something is, say, system provided, or as opposed to coming from one of the configuration data stores. Now, there is additional activity still going on in the IETF, and one draft I found that was kind of interesting is that obviously trying to compare what's in, say, intended and operational might be, computationally intensive for the client. So there is a draft which is under review to introduce new operations, new RPC called compare, which can return differences between data stores. And again, you can supply filters, subtrees, XPaths that kind of limit the scope of the comparison. But the idea is to make this, easier for clients to use. So with that, I'm done. And again, hopefully we have a little bit of time.
Yep.
Nabil, if you've got some questions.
Yep. Thank you for a great presentation. We have 5 minutes left. I would ask everyone to please add your question in the Q&A section. The last question here, an unanswered question. It's how does get data on operational work, on the operational data store work on nodes with persistent true tailf extension? So these are config false data. Yeah, how does get data? Is there a special behavior of get data, or is it similar to the previous get just a get RPC?
Yeah, so for things in your data models that that you're going to be supplying the information for, depending on where the source of that information is. So either if it's through a data provider, ConfD will continue to invoke your data provider. If it's CDB OPER data, then if it's config false data, but it's being stored in CDB, then ConfD will read that data from that data store. So you're expected to kind of keep, the sort of operational state aspects of the of your platform and what's stored in CDB kind of consistent, right? Because ConfD is just going to want to read the data from whatever source you've kind of specified. Will be returning the value. Hopefully, does that answer the question?
I think so.
Okay.
Again, if you satisfied, or if you have another question, let us know. I think it's good. So okay, all of the questions were answered in the Q&A. So this was the last one. Thank you everyone for joining us today. I will, of course, share the recording, and if you have any questions, follow-up questions that come up later on, feel free to reach out to me, and I'll be able to address those questions. Thank you for participating in the poll. And with that, I say to the next workshop. One of the questions in the poll was to get some suggestions, so we can see what you're interested in with regards to topics. I didn't get any answers there, but if you have any specific topics in mind, please reach out to me or to your contacts, any of your contacts from TALF, and then we should be able to address those. All right, thank you.
Okay, thanks.
Great. Bye, everyone.
Okay, bye.